Thanks everyone for coming. I know it's one of the last sessions on the last day here, so good to have you. I'm going to be talking about environments where you have a lot of computing resources, virtual machines, servers, and how to make sense of all of that using the firewall, and how to make sure that your security policy is always in line with what's currently going on in your compute environments. So I'm joined today by Carl Foster from the Belk Department Store Company. And after I go through an overview of some of the capabilities of the firewall, he's going to go over how he actually uses it in his environment today. So one of the best ways to handle all the computing chaos in our environments, one second. Yes, thank you, Mac. All right. Is dynamic address groups. So with dynamic address groups, what we're doing is actually, they're very similar to regular address groups that you would use that contain IP addresses. You add your IP addresses to these address groups and put them in your policy. But the difference with the dynamic address groups is that you're not the one that has to add the IP addresses. You're using automated systems to add IP addresses into these environments. Quick show of hands, who's used dynamic address groups before? All right, cool. We got a few people in here who have used them before. So I'm going to cover dynamic address groups at a high level, and then we'll talk about some of the ways that we can get the data into these address groups. So in the GUI for PanOS, you'll see under Objects tab, there's these regular address objects and address groups. Now with a typical address group, you're going to add address objects to that group. But what we're going to do is change this address group from a static group to a dynamic group. And then rather than adding the address objects to it or IP addresses to it manually, what we're going to do is add some tags as a match criteria for this group. So in this case, I've created, it's kind of a little hard to see on the slides up there, but the name of the group is New York Web Servers. And I've added 3 tags with a match criteria. So the match criteria is the tag New York and Web and Linux. So I have 3 tags with ands in between them. I can use ands or ors to make the match criteria for this dynamic address group based on these tags. So, excuse me, let's zoom out for a second and talk about, we have all these compute resources, right? We have servers, maybe they're physical, bare metal servers, maybe they're virtual machines in an environment. And each of these servers usually has an IP address, right? So we communicate on the network. And these servers all have different purposes. So maybe some of these servers are running Linux, some are running Windows, some are used for web servers, some are used for database or SharePoint. Some are located in New York, some are located in London. They all have different attributes. I'll call that metadata about the server. So what is the purpose of that server and the characteristics of it? And there's typically some kind of resource management system handling all of this compute environment. So usually you'll have something like either VMware or OpenStack. There's a lot of different kinds of resource managers that you could use to spin up these different servers. And typically speaking, that resource management system will know the purpose of the servers in some way. It'll know what tenants they belong to if you're in a multi-tenant environment, or it might know what operating system they're running. Sometimes it'll even know the purpose if it's running a particular application like a web server. So how can we get all that information, sort through it, and make sure that the firewall can use that information? So here's my dynamic address group again, so New York Web Servers. And so I have my security management system. That could be Panorama, it could be a script that talks to Panorama. Whatever I'm going to use, I'm going to get my resource management system to talk to my security management system. Maybe that's OpenStack talking to Panorama, maybe it's something else. But essentially what that allows us to do is it allows us to match on particular attributes or metadata about these different servers. So for example, if I have 2 servers in here and they're both in New York and they're both web servers and they're running Linux, I can tag those servers as New York, Web, and Linux, which again is our match criteria for the dynamic address group. So because these IP addresses match that criteria, their IP addresses are automatically learned by the dynamic address group. So when you have your PAN-OS security policy set up, and again, the text is a little hard to read from back there, but I'll read it out to you. We'll have this top policy here called toMySQL, and we use our dynamic address group, which is New York web servers, and our destination, maybe another dynamic address group called MySQL servers. And because that dynamic address group has learned those two IP addresses, whenever those IP addresses try to communicate, it will match this policy. And when they're communicating with a database server, it'll be permitted. Now, if we add a new server, so we go into our resource manager, and we say, I need to provision a new virtual machine. And that's also going to be a new New York web server. It gets provisioned, and the IP is automatically added to that dynamic address group on the firewall. So your firewall policy, which you've already established, is now up to date and current with the current state of your compute resources. So this kind of changes the way that the policy is thought about, right? Because traditionally a firewall policy says IP can talk to IP. And then you can kind of abstract that, and you can use objects to say, OK, well, this group of IPs can talk to that group of IPs. But what we're saying here is we're kind of bringing it out of the IP realm, and we're using actual concepts, like real concepts, like the location or the purpose of a server. And we're using those to write our firewall policy. So we're saying New York web servers can talk to database MySQL servers. And what IP addresses happen to fit those categories is sort of immaterial to the policy. But when the firewall goes to enforce it, it has this information, this metadata from the compute or from the resource manager, the compute resource manager, in order to enforce the policy correctly. Now this helps also for decommissioning servers as well. Say we tear down this server on the left. Well, that IP is instantly removed from the dynamic address group. So you don't have these stray IP addresses that exist in your policy because someone tore down a server and never notified the security team, right? And that's a security hole, potentially. And so this would allow you to close that hole immediately when it's not needed anymore. There's a lot of systems that use dynamic address groups. I've put a few up here just as examples. But there are a lot. There are a lot. And there are more every day. And you can write your own, in fact. I'll get to that in a second. But just to take a few of these examples. So OpenStack, first of all. This is a screenshot of the OpenStack GUI. And we have our OpenStack integration installed on the OpenStack platform here. And so we have a new section called Next Generation Firewalls, where you can deploy a VM series or a physical firewall through OpenStack. And what that means is that when you deploy a firewall in OpenStack into a tenant, that firewall is going to learn metadata about all the VMs in that tenant, everything that it's protecting. And so you'll get these tags here. So what we're looking at here is on the PAN-OS GUI, I'm creating a dynamic address group, and I'm adding a match criteria. And it's showing me all of the tags that this firewall knows about. Again, it's a little hard to read, but what this allows me to do is create an address group that matches any virtual machine in a particular tenant, or any virtual machine on a network, a specific network. Any virtual machine that's owned by a user or that's running a specific operating system. Or I can just sort of group my virtual machines into security groups and OpenStack, and then have those security groups coexist in the firewall. So it allows me to create my policy based on logical concepts like tenants, networks, users, flavors of virtual machines, operating systems, things like that. Here's an NSX example. So in NSX, they have a concept of security groups, these groups of virtual machines. And those security groups translate directly into the firewall. So I can create a dynamic address group that matches on a particular security group, or I can do like an OR relationship, like this security group or that security group. Now, the other example is ServiceNow, but I'll show you that one in a few minutes because I can actually do that one as a live demo. So let's move on to another concept, VM monitoring. So VM monitoring ties very closely with dynamic address groups. But you notice that in the examples I showed you so far, like OpenStack, VMware NSX, what's happening in those cases is some external resource manager, OpenStack for example, it knows about the virtual machines, and so it's pushing the metadata over to the firewall. So the firewall has that information and it's all synced. VM monitoring is the opposite. So with VM monitoring, the firewall reaches out to the orchestration system and it pulls that metadata. And this is useful for certain environments like when you have VMware vCenter, or like, so you don't have NSX, right? NSX will push that data. But if you have only vCenter, then you can pull it from the firewall. Also, if you just have one single ESX host without a vCenter, we could pull it from that. Or Amazon Web Services can pull from the cloud. This is a screenshot of how you might set up a connection to a vCenter in order to pull all the metadata about the virtual machines that it knows about. And then once it pulls that metadata, that will show up as tags, just like it would have with the other examples. So here's some examples of tags that might show up when you're doing VM monitoring with a vCenter. So you can match on the guest OS. In this case, we have CentOS, Microsoft Windows 7, Windows Server 2008. You know, the same attributes that you would see in your vCenter web interface, like the operating system, the hypervisor it's running on, the data center it's in. All of that information can be matched based on dynamic address groups, based on the tags. So in this example, what I've done is created an address group for all Windows 2012 Server Edition connected to vSwitch 0 in a particular data center. So let's kind of summarize. So why dynamic address groups? Well, the main thing is it simplifies your policy because we're not writing policy based on IP address anymore. We're writing it based on these higher level concepts. It also helps simplify change control because traditionally what might happen in this kind of situation is the compute resource is allocated and then that server has a web server on it. So that person opens a ticket with a security team saying, I need a rule put in that allows people to access this web server. Security team, depending on how much bandwidth they have at the time or their change control windows or cycles, they might say, okay, well, we'll add that rule in a week, right? Next change control window is this weekend. We can add it then. Sometimes it may be 2 or 6 weeks, just kind of depends on a lot of factors. What this allows you to do is have that take effect immediately. Because dynamic address groups don't require a commit. It's not technically a configuration change on the firewall. It's just metadata that the firewall is using in order to better enforce the policy that you've already set. So some people might have concerns about that, and that's understandable. But I would say think of it more like instead of, okay, I allocate a compute resource, and then I go and I change the firewall. Think of it more as like one atomic operation that's all approved at the same time. Right? So-and-so needs a new web server spun up, and so they put in the change request. Compute team, so the server team says, okay, I approve. Security team says, okay, I approve. And then the system is built in one atomic operation where both the compute system is brought up and provisioned and the security rule is automatically updated. So that means provisioning your resources is very fast, right? It takes out user error too, administrator error. What if someone types in the wrong IP or puts in the wrong port number? Well, it's irrelevant because the policy is already established. There's actually no change to the policy. And then again, when that resource is torn down, maybe it was used for a contractor for 2 months or for a trade show, and it's no longer needed, then it's automatically removed from the address group. Right? Again, with no change to the policy. So just a couple things to note if you're planning on using these. In PanOS 5.0, they're actually called dynamic address objects. And the reason for that is they're more focused on single tags, right? So in PanOS 5, they were called identifiers, not tags. And you could have one identifier per IP and one identifier per address object. In PanOS 6, it was scaled up incredibly. So there are multiple tags per IP address, like in my examples with New York, web, and server, and Linux. Multiple tags per IP, as well as multiple tags in the match criteria for the address group. So it just makes things a lot more flexible in the way that you build your objects. As well as we scaled up the number of IPs you can register in this way as well. It's up to 100,000 IPs on the highest platforms. I've given you a few examples of how of orchestration systems that we can support that work today. But let's say you have your own orchestration system. You have some system that knows all of the IP addresses and what they're used for. It could be anything. It could be maybe you have info blocks, or maybe you have an Excel spreadsheet with all that information, and you just want to get that into the firewall. You can do that using our APIs. So you can update dynamic address group tags with the user ID API. And just for reference here, this is the URL you would use to do that. You set a type and CMD, that's a command. And the command consists of a UID message, which I'll show you on the next slide. Those are the most important things. You can also apply it to a specific vSys, and you can have Panorama proxy this API call to a specific firewall by serial number. So the last two arguments are optional. Those are just for sort of targeting the API call. But the actual content of the API call is in that CMD argument, and it looks like this. It's a UID message. You always have the version, type, and payload. Those are always the same, so don't have to worry about that. You can copy and paste it. Then you have this command called register, and you have an entry. In the entry, there's an IP address. That's the IP address that you want to register some tags for. And then within the tag element, you'll have a few members. Those are the tags themselves. So again, in my example, New York, web, and Linux. So this will tag that IP address with those three tags on the firewall. And then you can match those tags, or any combination of them, with the dynamic address group. If you want to unregister a tag or an IP address, you just change the command from register to unregister. Now you can unregister just individual tags. So let's say this server changes purpose. So it's a New York web server running Linux, but we change its purpose to being a database server instead of a web server. We can just unregister the web tag and register a database tag. And we can do that all in the same API call. You just have to have, you can have more than one command. So you have one register command and one unregister command for that same IP address. Just for completeness sake, this is how you do it in PanOS 5.0. So the previous example was 6.0, because you can have multiple tags per IP. In PanOS 5.0, you can have one tag or identifier per IP. And so in that case, I would do it like this, where you have New York web and Linux all on the same line. You can verify that it's working, whether you're getting tags from VMware or you're getting tags through the XML API. You can use this show object registered IP all command to see all of the tags, all the registered IPs and the tags that they have. So here I have 3 registered IPs, each of them with 3 tags. Just a few other debug commands for your reference when you're working with these. So you can clear out all of the registered IPs. You can register IP manually on the command line if you want to. So it's really good for testing. I don't recommend it for production use. That's not the best way to get a registered tag in there. But it's good if you're trial running a policy. As well as there is an internal log that you can access on the command line that will show you any registered IP addresses. So you can go back and see, for auditing purposes, who registered what IP and what method they used to register it. One other thing to note, there's an activation interval for dynamic address groups. So this is kind of the sequence of events that would take place if you were to use a dynamic address group. So let's say you deploy a new resource, a new server, and then whatever orchestration system you have, OpenStack or NSX or whatever, it makes an API call out to the firewall to register that server's IP address with some new tags. Now those tags will show up right away on the command line. So if you go to the command line of the firewall and you do that command I showed you, the show object registered IP all, you'll see those tags right away. But they won't take effect right away. They won't be added to your dynamic address group until the activation interval has completed. So what happens here is the firewall will delay that process a little bit, because if you have a lot of different tags to update and you're updating them in sequence, it can get a little strange in the policy if you have race conditions or things like that. So we just delay the actual enforcement of that for a short time period. It could be up to 60 seconds. So it depends where in the activation window you have made your tag update. If you're early in the window, it could be full 60 seconds before these take effect. If you're late in the window, it could be just a few seconds. It's not something you really have to worry about, but if you are testing this in a lab and you're wondering why your dynamic address groups aren't showing the IP addresses, that's why. Just wait a minute and it should show up. This is also an interesting factor in the usage of dynamic address groups. Now, mostly what I've talked about here is using them in a compute environment for servers. You might think, well, can I use this for clients, right? What about people connecting to my Wi-Fi? Can I apply tags to those people, to their client systems, and then enforce based on those tags? And the answer is technically yes. I mean, any IP address can be tagged with any tag. But because of this activation interval, most users don't want to wait 60 seconds before they can get on the network in order for that tag to update. So for client side, this isn't quite as applicable. It's mostly used for your compute resources in your server environments. All right, so let's go check out a live demo. OK, so I'm going to log into a firewall. It's called My Firewall. And let's do that command, show object registered IP all. You can also look at specific IPs or specific tags. We'll do this. OK, I have no registered IPs. Let's switch over to the firewall itself. All right, so I've created several dynamic address groups. You can see dynamic here. Let me enlarge that a bit. And the names are different kinds of servers. So what I'm doing here is I'm separating out my server IP addresses by the operating system. Right? So you could separate it by a lot of different criteria. I'm using operating system for this example. So I have one object for all servers. I have one for just Linux servers, Solaris. This is for all Windows servers, and this is for specifically Windows 2003 servers. If I click More, notice there are no IP addresses in here. I don't have enough resolution. There we go. All right. Yeah, so I can click More on any of these. There'll be no IP addresses. So going back to the terminal. Now what I've done is I've created this script. It's written in Python. And it's using our PanPython SDK. So this is a free SDK we have available on GitHub. And you can access it and use it to access our APIs. So it makes it very easy to access the APIs both from Python as well as from the command line. There's two components to PanPython. One is a Python library that you can use in your Python scripts. Or it comes with a command line component as well. And that allows you to just use Linux or Windows command line to make API calls very easily. You don't have to know Python to use it that way. What I've done here is I've created this sync ServiceNow asset script, and that's using PanPython as a library, this Python library. And I've got a few arguments here, so don't need to worry about all these. This is just like be verbose. And then I've added here, these are the credentials for the firewall. So admin, very secure, right? And the host name of my firewall called my firewall. So that just translates to an IP address. And then I have the URL, or FQDN really, of the ServiceNow instance that I want to communicate with, and the credentials to my ServiceNow instance, also very secure. Let's hop over to ServiceNow. So what I'm looking at is this server area. So I'm basically using the ServiceNow API from my script, and I'm pulling down all of these server assets. So we can look at all assets, or we can look at them by operating systems. We can look at Linux servers, Windows, etc. There's Solaris, AIX. So we have a few assets here. All right, so I'll go ahead and run this script, and it's going to tell you what it's doing. So it's retrieving assets from ServiceNow. There it goes. So it pulled 41 assets, but only found 14 that are really relevant. They have a host name, an IP address, and their server asset. Then it prepares a connection to the firewall. It gets an API key from the firewall. So the way that we interact with the API on the firewall is we first get an API key, and then we use the API key for all subsequent API calls. That's all really well documented, so I won't go into too much detail there. And then what it does is it synchronizes the metadata from ServiceNow to the IP addresses in the dynamic address groups. So now let's switch over here. Actually, sorry, let's switch to the firewall itself. We'll do that same command. All right, so now we have a bunch of IP addresses registered, and they each have tags. Now, I created these tags. I thought this was a good format for ServiceNow. So I have SN for ServiceNow, dot, and the attribute type. So in this case, class, type, and OS, and then the value. So the class, let's see, what's a good example here? Class is Linux, and the OS itself is Linux Red Hat, and it's a server. There's a lot of different tags in here. Like we had 14 assets, so we should have 14 IP addresses in here. Here's another example. We have class Windows, and the OS is Windows 2003 Standard. So these are just tags that my script created. You can use any kind of tag that you want. I like the dot notation. And hopefully, if my 60-second activation window has expired, hopefully, and they'll show up here as well. There we go. So now, under all servers, what I'm matching here is the tag sn.type.server. And so all of the IP addresses are servers, so they should all show up here. In Linux, I'm matching sn.class.linux. And I can see all the tags here if I go add match criteria, right? There's all my tags that you just saw in the command line. So the Linux servers should show up here. There's only 4 of them. Same thing for Windows 2003 servers. So here I'm matching the OS instead of the class because I just want the specific operating system, Windows 2003. Click More, and there's the Windows servers. So now I can build policies based on these address groups and use them as the source or the destination of each of my firewall rules. All right. So now I'd like to bring to the stage Carl Foster from Belk Department Store Company. He's going to talk about how he uses dynamic address objects in his environment.
Thank you very much. How's everyone? So I'm here basically just to say this is not just a sales pitch. This is real. We really did it. It's really possible. It really can happen. He gave a great demonstration on ServiceNow, and I know everyone has all of these great platform management. All we had is Excel. We kept all of our stuff in it. Does anyone ever use a spreadsheet? I mean, does anyone keep any of their IP addresses and their information on the spreadsheets? Yeah, I'm sure they do. But even with the spreadsheet integration, it is possible, and the dynamic address objects make it very, very simple. We were able to deploy 300 units into our stores and get everything synced and configured in a week. 1 week, 300 units. So it absolutely is possible. Palo Alto has done a great job. This is just a kind of an overview of the network that we had, the network topology at our stores. we have some information, data center. We have a couple data centers and headquarters and a mainframe connected, pretty typical MPLS primary connection, VPN, and then putting in the firewalls in the compliance section on the right side is what we're talking about. But what we really think of is, okay, well, we have all these devices on the backside. The CSP additions is what we call them for our customer service platform. And you think of things like, well, you have some IP phones, you have some PIN pads and registers and some payment processing devices and those types of things. And that is exactly what we called our address groups. That was it. So we said, okay, so all of our registers, you guys over here, registers, you all can talk to these other servers at corporate. And so we have the list of registers at each store, and we have the list of the servers at corporate, and we created the single rule with the applications that they were allowed to talk. Then we used the API to go to each of the firewalls and push down the register that existed at the registers that existed at that store. And one policy allowed that communication to happen. So I like to say that it makes firewall rules that are so easy that even an executive can read them. It really does, because you start to think about your devices in the types of groups that the business thinks about them. It's like, okay, what are we trying to do here? We want to put out a bridal kiosk to do wedding registration. Okay, well, they're going to have some different types of things in, or they're going to need to be able to communicate with the mainframe to do item lookup, and they're going to need to be able to communicate with the register or the price list to do a price lookup, and then they're going to create some database server. So we have 3 rules, and they're all tied to bridal kiosks. So you could create a group called bridal kiosks, and the groups of the different servers, you create 3 rules, and everything talks. And you move a bridal kiosk from one store to another, you move it over on the tag, and it works. It makes life and management so easy, because we are, as a collective, as a group of people, we like to work smarter, not harder, and we really want to automate what we can. Any questions? Real world, tactical.
When you create your dynamic address groups, we're in the process of doing a rollout. When looking at this, saw the benefit. We ran into an issue with adding items to the dynamic address groups that may not have existed as a policy in the first place. So do you all your dynamic address groups under the shared policy, and you should have the replacement lab?
So we did that. We ran into that same problem. We had to push the tags first, but then I discovered in a previous session here at Ignite that you can do what, loose addressing, is that what it's called, where you can set up your dynamic address names without having to have the tags looked. It's a command that you run at the command line that you don't check enforce policy or something like that. Come on, Brian, help me out.
Yeah, I mean, you can create the dynamic address groups and your match criteria without the tags actually existing yet. And similarly, you can create the tags without having them matched by any dynamic address group. Does that answer your question, though?
It does. There's an on-off switch as to whether or not it'll allow it to be applied in policy. When we were trying to look at our policy fail, the objects were very tagged or vice versa. So I'll fix it.
Yeah. So yeah, I think. Yeah, we did have to. Eventually, they had to both live there, and what we did first, we had to push the tags to the local firewalls, and then push the policy down, and then it would commit. No problem. Anything else?
That might also be a little different in 5.0 versus 6.0 as well. So just something to think about.
Spreadsheets, how do you manage the change over time?
So, again, we don't have the resources that we have one person that's responsible for the spreadsheet. But what we do is, in our change control process, when you provision a new device, you have to fill out a form that tells what tags it gets, tells a little bit about what each server is, and that's part of the provisioning process. So with that provisioning process, you simply insert that in there, and that you can push if there are any changes that are affected, you simply push that out. And what we did is, in the spreadsheet, if I could go back and to one of your previous slides that shows the API call, yes, here. That HTTPS, we simply developed a formula that concatenated all of that, used an HTTPS command, assigned it to a button. It was a macro that just took a little bit of time to run. You hit it, and it goes out. So these commands, and they take just a second to run. So you can push out and update your objects that way. And it's a real simple spreadsheet, and I know that there are lots of examples available in the development. Dev Center, I think, is what they have at Palo Alto Networks on the website. So you can get some examples of how to do that and make that happen. Yeah, we did a simple Excel macro that did that.
Your security zone type of architecture now, is it a simple trust on trust, how do you incorporate it, or do you use multiple layers of security zoning?
We use several layers of zones. We have, I think, 5 or 6 zones, and we also use a lot of VLAN segmentation. The big initiative was PCI compliance and corporate data compliance, security enforcement. So we went from a relatively flat environment to something that was very, very segmented. We're actually also using the routing capabilities of the firewall to do some of our routing for all of our PCI and secured VLANs. So we terminate those gateway or those routes on the or those VLANs on that gateway. The non-protected go to the router, and so we have some additional segmentation and security enforcement there. So that's we like that. That's one of the things about the Palo Alto Networks devices that we like, is that they can do routing. They've got OSPF. They've got some other things. If they could get BGP here in a little bit, I don't know. But it's really nice to be able to do some of your core routing, make your routing decisions there as well. We do. And we also use it for, we use them for our routing. So if we stand up a new VLAN, we do add a sub interface, and we can push it out that way as well. Any other questions?
When you do clean up, or let's say, like you mentioned, you take a kiosk from one location to another and change the IP address, how do you then automatically change that firewall?
So if we had one of those whiz-bang ServiceNow types of things, it would automatically happen, but we rely on our change control process that updates the spreadsheet that says, okay, this object is moving from here to here, and it triggers 2 events. One is a decommission, one is a commission, and it pushes that out. No, go ahead.
Yeah, so the question is, for VM monitoring, is there any trigger that you can use to trigger an update to update the tagging, right? Is that right? Yeah, so with the VM monitoring, because it's a poll mechanism, it's actually based on a time interval. I believe the time interval is configurable in the VM monitoring settings. But yeah, so it would poll VMware or AWS periodically to get all the latest tags.
Would there be any kind of cleanup mechanisms or the stable type of thing
Yes, the question is there any way to sort of determine that an IP address hasn't had a hit in a long time and then remove it that way? So not exactly, because if the IP exists in the firewall, if it's tagged, that means it exists in VMware, and it's a live virtual machine that is, up and running. So in that way, since it is a commissioned virtual machine, it does exist in the firewall. But that being said, there are mechanisms in the firewall to detect unused rules and do some of that cleanup. So it's not a dynamic address group specific feature, but there are ways to find those unused situations. Yeah.
Anything else? Go ahead. Go ahead.
Excuse me. Yeah, so that's a great question. So the question is, at a high level, how is Panorama involved in all of this? And I didn't really cover that here in the slides, so I wasn't sure how much time we were going to have. But to dig a little deeper on that, the firewalls hold the tags. So Panorama doesn't maintain a list of tags. Like when we saw that command that I typed, and you can see all the IP addresses that are registered and all the tags that they have, that command doesn't even work on Panorama. So it doesn't maintain a list like that. But in PanOS, you can designate one of your firewalls as sort of like a master user ID firewall, and then it will share all of the registered IPs and tags with all of the other firewalls, and it will share it with Panorama. And so that way you can use Panorama to build your dynamic address groups and see a list of all the available tags to build your policy from. But since Panorama doesn't actually do the enforcement part of that, it doesn't maintain a list of tags to enforce with. So hopefully that answers your question.
Why does that differ from what happens within NSX configuration, where Panorama is being notified by Service Composer when a dynamic access group changes, receives that change, and then pushes it down to the firewall? So
yeah.
It's obviously keeping track of at least the dynamic access groups in order to push that down.
Yeah.
Is it just the tags when you're not doing NSX? Mm-hmm. It's the tags that Panorama doesn't keep?
Yeah, so the question is, how does that Panorama behavior I just described compare with Panorama's behavior in the NSX integration? Because with NSX, there's actually a whole menu item in Panorama for updating dynamic address group tags on your firewalls. And it's like a very similar mechanism, but it's kind of like baked in, you could say. So if you're doing dynamic address tagging updates through NSX, NSX will update the tags through Panorama to the device groups that you designate in Panorama and all the firewalls in those device groups. And that's all kind of a baked-in functionality. When you're using the API and spinning up your own solution, then you kind of can do some of that stuff. You can do the same thing, but you kind of have to do it in your own steps. So what you would do is you would look at the device group that you're interested in. You make an API call to find all the firewalls in that device group, and then just go ahead and through Panorama target each one of those firewalls with the tag. And that would kind of duplicate the functionality of the NSX integration. Or you can do what I described earlier, where you have one master firewall that shares the information with the other firewall. So there's a couple different ways to do it depending on your situation.
With the idea that you don't necessarily have to push policy to allow access, if you have external auditing from like KPMG or how, and it's just a general question, how do they see that and how do they react to it? Where somebody stands on a web server, the network team didn't take any action on it, and all of a sudden it's allowed access to different areas.
I think the wider question there is for a compliance organization, keeping track of what those changes to those dynamic address groups were, so that you could go back 6 months and say, well, yeah, at that point, he was a member of the group.
Right. Yeah,
Go ahead. I'm not sure.
it's the responsibility for that, so to speak.
Yeah.
Who's tracking the compliance, and are you, so you're tracking the changes in your spreadsheet via change management
Right.
roles. And so you've got that to fall back on. Is Palo Alto keeping track of those changes to who was a member of the dynamic access group? When did that change? Is it being dumped to logs? Is it?
Yeah.
Yeah. You want to go ahead and talk, because I know that was always being logged, yeah.
Yeah, sure. So I can talk about it, kind of in the general sense. So there are logs that exist on the firewall that show whenever an IP is registered or unregistered and how it was registered. So that all exists on the firewall. That doesn't syslog off the firewall today. So that's something that may be added in the future. But today, if you wanted to keep a historical record of that, you would maybe have a script that pulls it from the firewall through the API.
That sounds like something that really needs to be 100%.
Yeah, exactly, yeah. So it's a good idea. But in general, when we're talking about, like your question was around change control and security teams versus server teams and everyone interacting.
I'm more worried about the compliance aspect.
In the compliance aspect,
if
yeah.
USA's walking in and beating you over the head, you can't tell them what was in a dynamic group 6 months ago.
Yeah, that makes sense. So for auditing purposes, there's a couple different things you can do. So you can have an external audit mechanism based on the compute system. So the compute system has a log. You could perhaps rely on that as your log of dynamic address groups. If you also want the log from the firewall, there's a way to pull that from the firewall. It just doesn't syslog out today. And then around the question around security groups and workflow operations around change control, my take on that is that while those are two separate groups today, and server team might bring up a compute resource, and the security team has to make the whole to allow access to that resource. I would think of that as just sort of one operation, right? Where both teams are involved in a single operation. You take that human error element out of it, right, while writing the policy, and it all kind of happens at once.
I have a question. Could you solve that problem using a tool like it requires, which does your configuration of your clients, and then whenever change is done, you're doing daily checks, recording of snapshots, by keeping that for a group, and that would solve the compliance problem?
The other direction is to make sure that whatever mechanism you're using that's firing the API, whether it's your Excel macro or it's your web application that you're doing, to maybe provide some RBAC control in front of that change. You can have it fired off right there to the log and say, okay, I ripped it out, I added it. So there are other ways to do it. I was just trying to see whether or not it was available.
Right. Yeah. And one of the things about the API call is every time you submit an API call, it does give you a response, so you can keep that response log in there. So you can say, okay, this was a successful change, this was not a successful change, so you can tell, get immediate feedback if it was successful. And you keep your change control logs, take snapshots of those daily or periodically so that you can go back and reconstruct it.
Actually, that's an interesting question. Does the usage of the API dump the syslog?
Usage of the API alone doesn't, but the action that you take does create an IP registration log, and then any traffic that matches that IP address would then create traffic logs and other kinds of logs.
How long are they kept for? Different size?
Yeah.
What's that limitation?
The question is how long, what's the retention policy around logs? So for traffic logs, threat logs, or anything having to do with things going through the box, those can be syslogged out or sent to Panorama for longer retention than the firewall alone is capable of. But because we don't syslog the IP registration logs today, those would be retained until the log cycles. So there's a certain amount of log memory, retention you have. And then if you're registering IPs every single day, you might run out of that and it'll cycle back over them. If you're not registering them very often, then it could retain for a very long time.
Very slick.
Any other questions? All right, we're right on time.
All right. Thanks,
Thank you so
everybody.
much, everyone.